Hello everyone, myself Devashish Das, Assistant Professor of Electronics Communication Engineering Department of Greater Kolkata College of Engineering and Management. Digital Signal Processing. In this video, we are going to study about the different topics of digital signal processing and its application, how digital signal processing can be applied in different field and how the different topics is present in the digital signal processing. We are going to study about this in these videos. Digital signal processing. This course is mainly for BTech students of Electronics and Communication Engineering of 5th semester. The subject code of it is ECE 504. Hello everyone. Before we are going to move in our main topic, first let we discuss what is analog and what is digital signals. Instead of signals, we are going to explain the systems also. So we are moving forwards to see what is analog signals or system and what is digital signal or system. Let's move. Analog and digital signals. Definitions of analog signals. These are the topics we are going to cover in this session. First we describe analog signal and digital signals, then the working of the analog and digital signals, examples of analog, pros and cons, that means what are the advantages or disadvantages of these analog signals, example of digital signals, what is the advantages and disadvantages of the digital signals, and after that, last but not least, we will discuss some of the applications of these analog signals and digital signals or systems. Let's move to the first definitions of analog and digital signals. First comes the analog signal. Analog means it continuous in nature, and next thing, it is infinite range of value. We will discuss step by step. More exact value but more difficult to work with. We will explain each and every point of these analog signals. It is continuous, it has infinite range of value and more exact values but difficult to work with. Instead, case of digital signals, discrete, it is discrete in nature, finite range of value, not exact as analog but easier to work with. That means it is more easier than the analog signals. Both of has its pros and cons. That means both of has its advantages and disadvantages in our system. We first explain analog signal. After that, we will explain the digital signal. First, we are going to explain the analog signal. See, here we can see a signal. That means a signal, you can see that here is a signal, it is an analog signal, and in the right side we have a digital signal. In the left side we have analog signal and right side we have a digital signal. In the left side we have analog sinusoidal wave signal, in the right side we have a square wave digital signal. We will explain why it is analog and why it is digital. First we have seen that the analog signal is continuous in nature. That means we can see it is move continuously from zero or initial value to its peak value each and every step, or if we cut it in different way, each and every point we can get a value of this signal. So that is why it is analog, means it continuous in nature in the amplitude domain. The signal has two domain. This is two domain signal. In x-axis there is a time, and the y-axis it has a voltage. You can see the voltage is continuously increasing, and it moves to a top peak position and it decays down towards, and it is going in the minimum positions and it's moving up continuously in nature. That is why it is called the analog signal. In case of digital signal, we can see the amplitude domain. The amplitude domain is the key domain to identify whether the signal has discrete nature or the analog nature or the digitized nature. That means a digital signal or the analog signal can be classified with the help of this amplitude domain. If the amplitude domain is continuous for the signal is called the analog, and if the amplitude domain or the voltage domain or y-axis is discrete in nature for the signal, then the signal is called the digital signal. Here we can see a digital signal which is discrete in amplitude domain or the voltage domain. Here we can see it is voltage domain, so the signal has a either 0 value or it has 5-volt value in the domain. In this way we can distinguish the analog signal or the digital signal. So it is another thing, it is a continuous signal of a period. It's a period of 2 pi. Total time period is t. We can see a full oscillations over there of 2 pi. Similarly, it is also a periodic signal. A complete cycle is moved over there and ends over there, over here. So it is a complete cycle. So in both are periodic in nature, but it is in the left side it is an analog signal and it is a digital signal. Digital signal can be also classified as a high or low. It has either high value or low value, and in this way we can classify the signal into two categories. Either it is a continuous analog signal or it is a discrete digital signal. Continuous in amplitude domain and it is discrete in digital domain or the amplitude domain, that is it is called the digital signal. We are moving forward towards the difference in working, how the signal varies time to time. That means in case of working, the working of the digital signals are more reliable and it's more accurate. Now we can see our whole world is converted into a digital world. That is why the digital is more famous. It is more accurate compared to analog signals. Digital signals are used to play the informations. That means we can store more information in a digital form rather than analog form. Digitized information can be stored, but the analog can be, but it is more costlier or the more hectical than the digital one. Digital one is very easy to keep stored and process it. Digital signals have property over analog signals. Digital signal have the priority over the analog signals. That means the digital signal is more famous rather than the analog signal, because the digital signal can be processed or can be used in a easier fashion than the analog signal. But in this case, I want to say something, that the whole world is analog. The whole world is analog. We can process the digital signal easily, or can store the signal, or the value of digital signal can be, or digitized system can be easier the manufacture, or can be processed easy, but the whole world is analog. We have to deal with the analog system also in part to the digital signal or the systems. Let's move to the next stage. It is the example of analog devices. Here we can see a headphone, a speaker, a thermometer, and a microphone. These are all the analog devices. The headphone is the output of the audio system in the analog form. The speaker is also a audio system output, audio analog signals output. It convert the electrical signal into sound one. The thermometer, we can see it is an analog thermometer. Here you can see the analog thermometer over there. It is an analog thermometer. The thermometer, the reading of the thermometer is continuously increase or decrease depend upon the temperature, but it is analog in nature. That means each and every moment we can get the value of this thermometer. It is the microphone. The microphone converts the audio signals into the electrical one. It take input, the audio as input, and produce the electrical signal as a output. This is the functions of the microphone. And also the output of the microphone is also a analog electrical signal. These are there are many other analog devices, but these are the few. What are the advantages and disadvantages of the analog signal? We discuss one by one. First comes to the advantages. The major advantages of the analog signal is infinite amount of data. Design density is much higher, easy processing. These are the advantages of the analog signal. Now come into the disadvantages of the analog signal. It is unwanted noise is recording. If transmit data at long distances, then the unwanted disturbance is there. That means for the long communications there will be a loss of the signals. Generation loss is also a big problem of the analog signals. Yeah, it is the noise which is most important thing in the analog signals. We can merely or slightly remove, or the noise reduction technique in the analog system is very difficult. The noise reduction technique is very difficult. If a noise get injected in the analog signals, it is very hard to remove those noises from the signal. That is why we are very much bothered about the analog signals. Now move to this is the example of the digital signal devices. We can see a digital clock, laptop, desktop, iPad, or swipe machine. These are the all example of digital devices. We are talking about the digital watch. A digital watch is, you can see over here, it show 9:51. It cannot show any value between 9:50 or 9:51, which can be possible in a analog watch, though it is a fraction of seconds, but still we can get the value, or we can fetch the value from the analog watch, but we cannot fetch the value, or we cannot get the value from the digital watch in between 9:50 or 9:51. But still the digital processing is much better than the analog processing. That is why digital and analog both are required in our world, but digital is slightly better than the analog in case of storage or in case of processing, but our the whole world is the analog. We have to keep in mind both simultaneously. These are the advantages and disadvantages of digital signal. The advantages, because of their high digital nature, they can be travel faster in over the digital lines, ability to transfer more data as compared to analog. Disadvantages are the greater bandwidth is essential. Bandwidth means the more data can be transferred, or the speed. The bandwidth depend upon the speed in terms of oscillation speed. That means in kilohertz, megahertz, or gigahertz, or terahertz. These are the speeds or the bandwidth of the digital systems. Systems and processing is more complex. These are the disadvantages. For higher bandwidth we require more investments, mean more cost will require, and the system complexity if goes up, the cost will also goes up. These are the disadvantages of the digital processing, but analog and digital both are important in nature. We come to the almost to the end. We are now going to discuss about the applications of the analog and digital systems. First we discuss about the analog systems. The thermometer is there, we have discussed, it is continuous. The photocopies, the earlier days we take photocopies. The old landline telephones, these are the little bit old fashioned technologies, or the examples we are discussed over here. They are analog in nature. Audio tapes, VCR box, the old fashioned TV are also analog. There are many examples of analog systems, but we are discussing few of them. Digital, in case of digital example or applications, there are lots of, the whole world is basically a digital world nowadays, but we are moving to the digitals. The PC, that means personal computers, pad, iPhone, they are all digital ones. Mobile phones and all the gadgets we use in our daily basis, they are all digital in nature. But we have to keep in mind that the whole world we are seeing or we are hearing we smell, they are all analog world, but we have to convert this analog into digital for our benefits of storage, speed, transfer, etc., and the cost also. We just convert the analog into a digital, then process it, and we are going to again recollect them from the digital to analog. In this way, we have to keep in mind the both of them, the analog and the digital, both of them has to be kept side by side and process them to get a better world. Thank you for watching. If you have any queries, you can contact to me. The contact number is given. The same number can be used as WhatsApp number. If you have any queries or doubt, you can call me or WhatsApp me to this number. Thank you very much.